Hello students, I am Ishan Trivedi. Welcome you in the video lecture series. Today we are discuss about behavior of brick masonry during earthquake. Topics to be covered in the sessions are earthquake design, philosophy and construction materials, behavior of brick masonry construction during earthquake. Let us start with the earthquake design philosophy and construction material. Based on severity of ground shaking at a given location during an earthquake, these are classified as minor, moderate, and strong earthquake. In every year, you will feel minor and moderate earthquakes having magnitude of minor earthquake near to 5 to 6, whereas for moderate earthquakes it is of 7.1 to 7.9. Whereas strong and rarely occurred earthquakes are very rare. It is like once in a 500 years or once in a 2000 years. In minor earthquake, there is low and repairable damage occur, while in strong earthquake shaking, there will be collapse of the structure. You can see here, there is collapse of structure in its own axis. Building is simply collapse just due to rare but strong earthquake force. So you have to understand the general principles of earthquake resistance building planning, the materials and the structural design of each components. And this will be referred from IS 4327. In city or in any town, buildings are shaking in different magnitude and with different intensity. So, if the buildings are closely spaced, may tend to damage each other by earthquake shaking. So, it has to be separated as it was discussed in previous session, as well as due to variance of its height and dimension, the precaution has to be taken while determining the building design. Now understand the weakest part of the building component. That is nothing but a masonry structure. In construction material, we have seen that masonry walls are strong and resist the earthquake force in compression. But if I pulled away or if there is a tension or axial pull is there, then it will be weak. And this is one of the most reason of cracking or collapse of any building structure. Understand, the masonry wall is weak in tension and strong in compression. Now understand the behavior of brick masonry structure during earthquake. As I said, masonry buildings or masonry structures are brittle. A number of earthquake feature, or you can say earthquake resistant feature, can be introduced to achieve this objective. And ultimately, we can reduce the effect of earthquake in the masonry building. Understand here, I am going to talk about only masonry structure. So do not have any confusion that how it is possible that the building or masonry wall is going to collapse. In the real practice, you will find the frame structure or combined structure, and certain rules and regulations are or the any design feature are not implied to those structures. It is only meant for purely masonry structure. Understand these things. So the ground vibrations during earthquake cause inertia force at the location of mass in the building. These forces travel through the roof and walls to the foundation. These things already were discussed in previous session. The main emphasis is on ensuring that these forces reach to the ground without causing any damage to the structure. Furthermore, out of these three structures like roof, wall and the foundation, the walls are most vulnerable, or you can say weakest part, which is damaged by horizontal earthquake forces. So horizontal earthquake forces are one of those dangerous forces which act upon wall, roof and foundation. Among all these three components, wall is very much affected by these horizontal forces, and that's why the ground shakes simultaneously in both the direction, like in vertical direction and in two horizontal direction, like x and y is horizontal direction and vertical direction is z direction, and the ground is simultaneously shaking in these two phenomenon, one vertical to horizontal, one vertical to horizontal, during earthquake. However, these horizontal vibrations are most damaging. See, there is only one vertical component and two horizontal component. So, in these two horizontal direction, these horizontal forces, or you can say horizontal vibrations, are most damaging to normal masonry structure. You can see here the direction of earthquake forces is on left to right, whereas the inertia force acting from right to left, which is in opposite direction, that is called push. If earthquake force is going through parallel to the direction of wall, then it is called strong wall. If the earthquake force is passing perpendicular to the direction of wall, then it is called weak wall. Strong wall is pushed in opposite direction of earthquake forces and there is only one moment, whereas if the earthquake force acting to the perpendicular to the wall, then inertia force largely taken by the wall, and that's why ultimately it creates bending in the wall, and which results into the toppling, or you can say toppling down of a wall, or you can say topple down of a wall, and that's why it is called weak. Strong wall is determined by A and the weak wall is determined by B. Understand this? Strong wall is determined by A and the weak wall is determined by B. So whenever I say that A and B, then understand that A is strong wall and the B is weak wall. Next, so as I said, this horizontal inertia force developed at the roof, which transfers to the walls and acting either in the weak or in the strong direction. See, the entire roof slab is covered with two weak wall and two strong wall. So whatever the inertia force is developed on the roof will share among to strong wall and the weak wall, which ultimately opposite to the direction of earthquake. If all the walls are not tied together rigidly like a box, you can see here the strong wall is tied with weak wall, so there is support of wall through interlocking of placing of brick masonry wall. If these walls are not tied like a box, you can see here the wall A and B, like weak wall and strong wall, are shown here, that is tied together. If this is not happened, or we are not providing certain treatment to the masonry wall, then it tend to topple down in the opposite direction of earthquake forces. So what we have to do? We have to prevent this toppling down of wall by typing together so that they are connected to each other and ultimately support and resist the earthquake force. Furthermore, Now let us take a vertical wall where earthquake forces is passing perpendicular to the wall. As this earthquake force passes to the perpendicular to the wall, the inertia force will act to the opposite direction, and that's why bending is created, which ultimately toppling down of the wall from its position. That is called flexural wall. Understand? This toppling down, or you can say weak wall, is called flexural wall. Clear? Where the earthquake force is transverse to the wall. Clear? So the wall is transverse to the earthquake force, and that is called flexural wall. Next is the wall which are parallel to the direction of earthquake shaking and are subjected to shear and bending in its own plane. Understand? The shear and bending in its own plane. In flexural wall, the entire wall is collapsed down, so its plane has changed. Earlier it was standing and now it has overturned, and that's why the axis of that wall has changed, and that's why it is called flexural wall, or you can say weak wall. And the next earthquake force is again in the same direction, but here the wall is now parallel to the earthquake force and there is only shear and bending in it, and here the shear and bending is done in its own plane, and that's why it is called shear wall. Here you can see earthquake force is on right direction where the bending and shear is done on opposite direction, and that's why it is called shear wall. It is simple to understand. This phenomenon and these basics will help in next session. So it is very much essential to understand this phenomenon like flexure wall, shear wall, what is weak wall, strong wall, what are the inertia force and its results to the wall with the position of earthquake force. So these things has to be remembered. As soon as the direction of earthquake force is changed simultaneously, so that the flexural wall becomes shear wall and the shear wall become flexural wall, and this is done in instantaneous simultaneously. It is like circle. First there is a shear wall, again the direction of earthquake motion is going to change, then this shear wall is now act as a flexural wall. So what is the behavior on earthquake force on the masonry wall is, as the direction of earthquake change, the strong wall will be weak wall and the weak wall will be strong wall. This thing would happen simultaneously, very in next succession. So as earthquake force travels further, there is the behavior change of these two walls, shear wall and the flexure wall accordingly. So this is what the basics of behavior of brick masonry construction during earthquake. I'm ending this session here. I hope you have learned from these basics. Thanks for watching this video.